we're going to explore types of chemical reactions. In this lesson, you should be able to write the formulas for the reactants, predict the formulas for the products, and balance the equation. Let's see how that's done. There are 5 types of chemical reactions that we're going to explore in this lesson. First is synthesis. Second is decomposition. Third is single replacement reactions. And fourth is double replacement reactions. We will explore all, and fifth, combustion reactions. We'll explore all 5 of these in this lesson. You'll need to be able to identify the type of reaction and then predict the products in each one of those cases. Some steps for doing reactions are, first, identify the type of reaction. That is it a composition? Is it a decomposition? Is it a single replacement? 2, predict the products using the type of reaction as a model. And then lastly, after writing the formulas for the products, balance the equation as the final step. One thing you need to be reminded of is that certain elements are diatomic in the free state. Oxygen, for example, is O2 as an individual element. So if we want oxygen gas, we write O2. If we want bromine gas, it's Br2. Iodine gas is I2. Nitrogen gas is N2. Chlorine gas is Cl2. Hydrogen gas is H2. Oxygen gas is O2. And fluorine gas is F2. Remember that they are only diatomic in the uncombined or free state. They are not diatomic in compounds. Synthesis reaction. In general, 2 substances, normally elements, combine to form just one product. Basically, A reacts with B, and we get a new compound, AB. An example of that would be hydrogen gas reacts with oxygen gas to form water. A2 is placed in front of the H2 and the H2O to equalize the number of atoms on both sides to show conservation of mass. Another example would be carbon, which is an element, such as in coal, reacts with oxygen to form carbon dioxide. That is another synthesis reaction, where elements combine to form compounds. Here is another example of a synthesis. Potassium, which we have here, is a metal, and chlorine is a diatomic gas. When the 2 react, we get a compound potassium chloride, KCl. Why KCl? Because potassium is +1 and chlorine is a -1, so the formula for potassium chloride is K1Cl1. You'll see here in the crystal potassium is +1 and chlorine is a -1. In order to balance the chlorines on both sides, since chlorine is diatomic, I need to put a 2 in front of the KCl. That gives me 2 formula units of KCl, 2 potassiums, 2 chlorines, and then I put on the other side 2 in front of the K to balance the potassiums on both sides. Elements combine to form compounds. That's generally what a simple synthesis reaction is. Let's practice. Sodium reacts with chlorine gas. See if you can write and balance this equation. Predict the products. Solid magnesium reacts with chlorine gas. See if you can predict the products. Try these on your own. Hydrogen gas reacts with oxygen gas. Right now I balanced the equation for that. Practice these 3 on your own, and then check the answers. You can pause this lesson at any time. Here are the answers. Notice that sodium and chlorine react, we get sodium chloride. Chlorine is only diatomic when it's by itself, so here is chlorine gas. In sodium chloride, sodium is a +1, chlorine is a -1, so they add up to 0, and sodium chloride is NaCl. Chlorine is diatomic as a free elemental gas, but not diatomic in the compound sodium chloride. In the second case, you've got magnesium reacting with fluorine. Fluorine is another one of those diatomic gases. Notice that there is a 2 here. This 2 was not carried over. It's a 2 here because magnesium is a +2 and fluorine is a -1. Third, here we have hydrogen gas. Hydrogen is diatomic gas. And oxygen gas, and we form water. Notice that the 2 here is because the oxide ion is a -2 and hydrogen is +1. Decomposition reactions. They occur when a compound, a larger molecule, breaks up into smaller particles. Sometimes those smaller particles are smaller molecules, or they can be elements. So the general format of this reaction is you have one reactant, upon heating, gives you 2 products. So you can tell the type of reaction simply from the format. Remember that composition was A plus B gives you AB. This time you have a single reactant giving you 2 products, a different format. The general equation then is AB breaks down into A and breaks down into B, where A and B could be elements or they could be smaller molecules. Water then can decompose. It takes electricity to do that. Water cannot be decomposed by heating. And we get hydrogen gas and we get oxygen gas. So here we have a larger molecule breaking down into smaller elemental molecules, hydrogen and finally oxygen. Another example is mercury oxide. Now mercury oxide does decompose with heating. Strong heating of mercury oxide breaks it down into mercury, a nice shiny silver colored metal, and oxygen gas then is given off into the atmosphere. Decomposition. Another view of a decomposition reaction. Here again is mercury oxide. It is a crystalline solid with a regular arrangement of atoms. When it breaks down, we get mercury, which is this silver coating we see on the test tube, and we get oxygen gas, which goes out the top into the environment. So here is a microscopic view of the decomposition of mercury oxide. The triangle over the arrow means heating. So consider that something like a flame.